Today, lesson 34B, solving square and cubic equations. We've been working a lot with simplifying and estimating and approximating square roots that are not perfect squares. We get to apply those things today in various types of problems, but our focus is on setting up and solving equations with a variable squared or an equation with a variable cube in it. And sometimes those are referred to as radical equations, which is why that is in parentheses. So, just a little bit of background knowledge. We did a little bit of work like this where we were approximating irrational square roots. And sometimes we're trying to figure out what it would be to the nearest tenth or the nearest hundredth, but just recall that this is what we do. And we are doing this in a couple of problems today. Remember, this is just an approximation, so whatever you get, you need to check, because sometimes what you get, in this case 11.6, is good, and sometimes it's a little bit off. So you do have to check, and we've talked about this in great detail. And when we were doing these problems, I gave you a little formula. And by the way, this works if you're approximating cubic numbers as well, or cubic roots. Works exactly the same way. And then we also yesterday talked about how to algebraically, using the multiplication property of square roots, how to simplify square roots, not approximate, but simplify them as far as we can by breaking each root up into the largest perfect square that will go into the number times some other root that would make the number that you're trying to find. And sometimes the roots that we're given are already simplified. So we're going to apply both of those things today. So I just talked about this. In the last few lessons, we've been working with square roots and a little bit with other roots. In geometrical terms, the square root function maps the area of a square to its side length. And this comes from the first two problems of today's lesson. So if I were to graph this square root function, y equals the square root of x, it would look something like this. So if I use a table 0 to 6, and you don't have to write any of this down, I'm just showing you how the square root function kind of works. And I figure out the perfect squares and estimate the irrational roots. And then I plot all of those. It looks like this. And what this gives me is something like this. If I know that the area of a square is 1, the side length is also 1. And that should make sense to you because a square with side lengths of 1 has an area of 1. At the same time, let's say a square that has an area of 3, it would have side lengths of 1 point something. And in fact, they happen to be 1.7. And that leads us once again to our first two problems for today. We'll start with a very easy one, and then we'll go from there. The area of the square below is 289 square feet. What is the length of a side of the square? Write your answer as a simplified root and as a decimal to the nearest tenth, and that applies if this is not a perfect square. So we know that we have a square with an area of 289. We also know that squares have all equal sides. So if we were to set up an equation to deal with this, and if I made both of those sides be represented by the variable x, we would have x squared equals 289. By the way, what would the sides of that square be? Be 17, right? Now, how could we get that? Well, if we take our equation, take the square root of both sides, the reason why I do that is because I want to solve for x, not for x squared. And to turn x squared into x, I would need to take the square root. So I also have to take the square root of the other side. So this one's nice and easy. The sides of that square are 17 feet. Nice and easy when it's a perfect square. Let's go to number 2. The area of the square below is 250 square feet. What is the length of a side of the square? Write your answer as a simplified root and a decimal to the nearest hundredth. So much like the last one, and by the way, number 2 is right below number 1. Much like the last one, we could set up an equation that looks like this. X squared equals 250. And then we take the square root of both sides. And we end up with x equals the square root of 250 feet. But two things need to happen at this point. We need to simplify that square roots. Why? Because we're asked to do that. And then we're also asked to write it as a decimal to the nearest tenth. So basically, within this one problem, we're applying what we've learned in the last two lessons. So I'm going to give you a couple of minutes to simplify that square root and then also to approximate it to the nearest tenth. So we were supposed to give this as a simplified root from yesterday, which is 5 times the square root of 10, or 5 square roots of 10. And then as a decimal, it should be 15.8 feet. Are there any questions on the decimal part? Are we good on that? Okay, so now let's go to a three-dimensional figure. The volume of the cube below is 216 cubic yards. What is the length of a side of the cube? Write your answer as a simplified root. Now, a cube is like a three-dimensional square, if you want to think of it that way, which means the length, the width, and the height are all the same. So in other words, all 6 sides are congruent to each other. And so much like the last problem, we can set it up as an equation. Since all the dimensions are the same, we can make all of those sides x, and that would give us an equation that looks like this. X cubed equals 216. Like in the last problem, we want to turn the variable portion to x. So in order to turn x cubed to x, we would have to take the cube root of that side, because the cube root of x cubed is x. If we're going to take the cube root of the left side, we then have to take the cube root of the right-hand side. So what are the sides of that cube? This is not the first time we've done the cube root of 216, by the way. There's 6. 6 times 6 times 6 is 216. So that means the sides of that one are 6 yards. All right, everybody do number 4. 28. So like the last one, here we have the given volume. All the sides are the same. And so we can make each of the dimensions there x. And so we can set up an equation that is x cubed equals 1,728. Like the last one, take the cube root of both sides. And the cube root of 1,728 is 12, because 12 times 12 times 12 is 1,728. Well, everything that we do from here in this lesson is based on the principles that we just dealt with in 1 through 4. But I want you to take a look very carefully at this next problem, which is in your notes. It says, solve the following equation. Write your answer as a simplified root. Now, this has nothing to do with squares or cubes. We're just solving an equation. But I want to remind you of one thing. Ever since you first started learning how to solve equations, back in whatever grade that might have been, you're trying to find the value of the variable that creates a true statement. And that's the thought process that I want you to go through when you solve this one. So I'm going to give you about another 20 seconds by yourself, and then I want you to have a brief conversation with your shoulder partner about what you came up with. And I can tell you, when we did this first period, maybe 10 people got it right. And some of you I know are thinking, wait, this is too easy. You're right. It is easy. So, we got 15, and finally, after a bit of discussion, we got that there was one other one, and that's negative 15. Now, instead of writing it like I just did right there, there's a shortcut way of writing where you just have numbers that are opposites of each other, and it would be like this. And so you might want to write this down. It would look like, and I'm just showing you, proving to you that 15 and negative 15 both work, but it would look like this. And we say this as x equals plus or minus 15. That means there's one answer that's positive 15 and another answer that is negative 15. Now, some of you had asked if you were supposed to write something in the rectangle next to that. Now you are supposed to. So the whole point of what I'm about to show you and what I want you to write down is a proof of why there are two answers in squared equations, but not necessarily so in cubic equations. So you don't have to write anything down here. If x, and I'm just making up 3 numbers, a positive number, 0, and a negative number. And I'm picking small numbers so that it's easier to see it. So if x is 1, the absolute value is 1. And if x is 0, the absolute value is 0, 0. And if x is negative 1, the absolute value of that is 1. Now if I take that to the square root of x squared, I get the same values. But if I take it to the square root of x cubed, I get, and actually that should say cube root of x cubed, not square root of x cubed. This should actually be cube root right there. But here's what this leads us to. This leads us, and this is where you need to start writing something down, that proof from this table that the square root of x squared is really the same thing as the absolute value of x. And the formal definition of the absolute value of x is this. Write this down. And I don't want you to freak out by that. All that is saying is this. If you have a positive number and you're finding the absolute value of it, the answer is that number. But if you have a negative number, the absolute value of that number is the opposite of that number. Here's what I mean. And I'll just make up any number. What is the absolute value of 5? You can see, when we have a positive number, the answer to the absolute value of that number is the same number. But if we have the absolute value of negative 5, what's the answer to that? 5. So when we have a negative number and we're finding the absolute value of it, it's the opposite of it. But the proof of this is this. When we are finding or solving a x squared equation, we have two answers. But when we are solving an x cubed, or the cube root of x cubed, there's only one answer. That's what we are saying right here. When we are solving an x squared equation, there will be two answers unless the answer is 0. But when we're solving an x cubed equation, there will only be one answer. And hopefully you remember that in the next few problems. All right, turn your notes over to the back side. I'm leaving this up here for just a second because I know a couple people are still writing things down. Number 5 says w squared over 5 equals 120. Anybody have any idea how I might start the solving process? Yeah, just like anything we do, we need to get the variable part by itself. So in order to get the w squared by itself, we need to multiply both sides by 5. So let's do that. And when we do that, on the left-hand side we have w squared. On the right-hand side we have 600. You need to now finish it. Notice the instructions say no decimals on this one, just simplified root. I'll give you about a minute. All right, so we take the square root of both sides, and we have w equals plus or minus the square root of 600, but the square root of 600 can be simplified to 10 root 6, so it is w equals plus or minus 10 times the square root of 6. Okay? All right, everybody try number 6. So in this problem, we need to divide both sides by 1.6 so that we can get the f cubed by itself. And once I do that, I have f cubed equals 64. This is not the first time that we have found the cube root of 64. 4 times 4 times 4 is 64, so therefore f is 4. All right, everybody now, let's go ahead and have you do all three. 7, 8, and 9. And then we will exchange with our shoulder partner. Before we do that, can somebody tell me why negative 4 won't work as well?
Because negative 4 is a negative.
Yeah, negative times a negative times a negative is a negative. We're trying to find the positive cube root of 64, not the negative cube root. We could find the negative if we were asked to, but we're not asked to. All right, once again, do number 7, 8, and 9. All three of them. So in number 7, we should subtract 14 from both sides, which gives us c squared equals 96. Take the square root of both sides. You can break that up into square root of 16 times square root of 6, which gives us 4 square roots of 6. But don't forget also the negative version of that would also work. So c equals plus or minus 4 square roots of 6. In number 8, we would add 28 to both sides, then divide both sides by negative 2. And yes, I realize we have n cubed equals a negative number. But a negative times a negative times a negative is a negative. So we can take cube roots of negative numbers, but not square roots. So we end up with n cubed equals negative 216. So it is n equals negative 6. And then number 9, we would subtract 12 from both sides and then multiply both sides by 3, which would lead us to this. I like the fact that some of you didn't just settle for no solution. You went ahead and gave it to me as an imaginary number. And just to refresh your memory, because we did talk about this before, but if we break up square root of negative 36 into square root of negative 1 times square root of 36, this by definition is the imaginary number I. This is 6. But the only thing we have to remember, we are solving an x squared equation. So if you're going to write it as an imaginary number, you need to make sure you write it the correct way. So either no solution, no real root, or plus or minus 6i for that. All right, we have 2 problems left. Now, your cone in number 10 doesn't have all the stuff that I have in here. So go ahead and fill in your cone so that it has a height of 9 and so on. And while you're doing that, this problem says the volume of the cone below is 235.5 cubic feet. What is the length of the radius of the cone? Now, every single time I've given you an X problems packet, I've given you the formulas. At some point, I'm going to have to take those away. But for this one, I'll go ahead and give you the formula for the volume of a cone. It is volume equals 1/3 pi r squared h, where r is the radius, h is the height. So there are some pieces within this problem that are given to us that we can go ahead and fill in. For example, we know the volume is 235.5, and I know the height of that cone is 9. And I guess one other thing that we do know is that the approximation that we usually use for pi is 3.14. So if I substitute all those 3 pieces in, I have something that looks like this. 235.5 in for the volume, 3.14 in for pi, 9 in for the height. So as you're going through here and solving this, we need to make sure that we get the variable squared by itself, like we did in all the previous ones. It takes a little more work in this one because the numbers are a little bit more difficult, but it's the same process. So there are lots of things you could do. I already talked about the 1/3 and 9, or you could multiply both sides by 3 if you wanted to. Lots of things you could do. But I'm going to go ahead and 3 goes into 9 3 times, and 3 goes into 9 once right there. And then from there, I'm going to go ahead, I believe, and multiply the 3.14 times the 3 to simplify that side, which gives me this. And when I walked around, I saw that's what many of you did. Then we have to divide both sides by 9.42, and we get r squared equals 25. If we were just solving an equation, we would get plus or minus 5, but we're dealing with a real problem here, and negative 5 doesn't make any sense for a radius. So therefore, our radius is 5 feet. All right, any questions with this problem? All right, let's go to number 11. Number 11 says the volume of the sphere below is 904.32 cubic meters. What is the length of the radius of the sphere? I guess in order for you to do that, you need to be reminded of what the sphere volume formula is. It is V equals 4/3 pi r cubed. I'm going to let you work on that by yourself for a minute or two, and then I'm going to have you get together with your shoulder partner and come to a consensus on what that radius should be. All right, so we have the volume 904.32. We know that pi is 3.14, or that's the approximation that we are using. From here, like the last one, there are lots of things you could do, but I'm going to get rid of that denominator by multiplying both sides by 3. And when I multiply this side by 3, I'm going to have a big number. And then when I multiply this side by 3, what happens is I no longer have the denominator there. So I'm going to have 3 times 904.32 equals, and then 4 times 3.14, which happens to be 12.56 r cubed. Okay, can somebody quickly do 904.32 times 3? What is that? Two, 7, 1, 2.96?
Yes, sir.
Okay. And then from there, of course, divide both sides by 12.56. And then you're going to have r cubed equals, I believe it's 216. And then we take the cube root of both sides, and we can see that the radius should be 6. So we're going to work a little bit more on finishing up this idea right here tomorrow to clear it up a little better. So once again, the radius should be 6 meters. All right, we are finished.